Solving quadratics by factoring and graphing. We're going to first start by looking at how to solve them graphically. This is very easily done visually. It's the place where the graph crosses the x-axis, otherwise known as your x-intercepts. There are three possible ways that you will see this occur. The first way is when the vertex of the parabola touches. That is one solution, and that single solution is equal to 3. A second way that it will occur is that the parabola touches it in two distinct positions. That will be -2 and 1. The third way that you will see this is when the graph of the parabola does not touch the x-axis. There are no real solutions to this problem. Instead, you will see two imaginary solutions. That involves the square root of -1, which is also known as the letter I. We will get into more detail about the third option a little bit later on. Okay, graphing the following quadratic equations on graph paper, we're going to find their roots. So the first thing I'm going to do is I'm going to do the opposite of b over 2a, followed up by the f of opposite of b over 2a. That's going to help me find its vertex. So that's going to be 2 over 2, which is 1. Plug in 1 for everything, and we get 1 squared, which is 1, minus 2, which is -1, minus 3, which is -4. Next thing I'm going to do is find its y-intercept. The y-intercept is located at -3. Plugging in 0 for all the x values will accomplish this. And next I will simply graph it. Sorry, no graph paper on this one. I think we can find it anyway. 1, -1, 2, 3, 4. Okay? And I'm going to go over 1, I'm going to go to -3 to get my y-intercept. And then I'm going to notice that there's no stretch nor compression here because that is a critical value on the parent function, which means I can go over 1, up 1 here. And from there I can go over 2, up 4, which puts me there, over 2, up 4, which also puts me there. That means that in graphing this parabola, if I graphed it on my dots, the solution is here and the solution is here, which is going to be -1 and +3. Likewise, vertex form, much simpler, no stretch or compression, but there is reflection. We'll get to that in a second. Right 2, up 1, put your dot. Over 1, down 1, puts it there. Over 1, down 1, puts it there. Again, my parabola here, crudely drawn, is this solution and that solution, which is 1 and 3. Solving by factoring, slightly different. Please take a few minutes to copy down these 4 steps, and we'll go ahead and investigate how those steps work in each one of these 3 problems. So first of all, look at question number 4. You'll notice that you have to factor this thing out by using the greatest common factor, which in this case is x. Now you get 5x minus 1 equals 0. Once we've done that, we're going to we're going to set each factor pair separately equal to 0. So that means x equals 0. That one was a simple solution. And 5x minus 1 also equals 0. Solve for x by adding and dividing, and you get 1/5. So the solutions to number 4 are x equals 0 and x equals 1/5. If you want to write it this way, please make sure that you write it as a set of solutions within brackets. Okay? If you put it in parentheses, it makes it look more like an ordered pair. Otherwise, you simply write x equals 0, x equals 1/5. All right, again, we're setting it equal to 0. All of the terms are on the same side. We're good. Step number 2, greatest common factor. That greatest common factor is 3. That leaves us with x squared plus x minus 2 equals 0. Factor completely, I get 3 x plus 2 x minus 1. Okay? In this particular case, the 3 does not play a role in finding the roots of your problem. All 3 does is designate that there is in fact a stretch on this particular problem. I can divide out 3 to the other side and you can see that it doesn't have any meaning. I can also distribute the 3 back in again, and you'll notice if you do that, it will not affect your end result. So either way, the 3 does not play a role in finding your solution. Instead, I'm going to focus on the 2 binomials, set them both equal to 0, x minus 1 equals 0. So that means that x equals negative 2 and x equals 1 is your solution. In this particular problem, we got to move the 5. We got to move the 5x over the other side. Once we do that, we get 2x squared plus 5x minus 3 equals 0. At that point in time, we need to factor this guy because there is no greatest common factor. So I'm going to multiply these two numbers together to get 6. I need the two numbers that will add up to or subtract from each other to make 5. Now this one is tricky because you'll notice that the first factor pair and the second factor pair will both work. Okay? Now we've got to focus right here on the symbol on the negative 3. In order to get 5, you have to add 2 plus 3. In order to get 5 from these two, you have to do 6 minus 1. Therefore, when you break apart your middle term, your answer is 2x squared minus 1x plus 6x minus 3. 4-term grouping gives you this. Factor out your greatest common factor, which is x, leaving you 2x minus 1. Factor out your greatest common factor, which in this case is 3, leaving you 2x minus 1. And when you factor this, you get x plus 3 and 2x minus 1. Setting both of those equal to 0, you get x equals negative 3 and x equals 1/2.